repeaters as fractions, this is where we begin at example 5. And this requires practice, practice, practice. All right? I'm going to try and go over several examples of number 5 and then number 6 with you before I give you the worksheet that you guys have. Example 5 is writing a repeater as a fraction. So let's start with the number 72 hundredths repeating, which is 72, 72, 72, so on into infinity. Okay? Step 1, make the repeater equal to x. In other words, x equals 0.72 repeating. Okay? And you know that what that means is it would be written 0.72, 72, 72, dot, 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 dot. You know this. You don't write it this way, you write it this way because that line symbolizes this knowledge. Okay? That's step 1. Step 2, count the number of repeating digits. In this case, how many repeat? Anybody able to count how many repeat? 2. Very good. And multiply by 10 to that power. In this case, it would be 10 squared, which is 100. Okay? I know this seems a little bit tricky, just bear with me. So we're going to take x equals 0.72 repeating, and we are going to multiply this entire piece by 100. That's what step 2 says to do. What is 100 times x? Go ahead, Sarah.
17.
How about 100 times x? Anybody want to answer that? 100x, very good. And what is 100 times 7272727272? This might feel a little tricky, but it would look like this. Okay? So that's step 2. Count the number of repeating decimals. There are 2. And multiply by 10 to that number power, which is 10 squared, otherwise known as 100. Which is why we multiplied. Step 3. Subtract whatever the x was. In this case, x was that. Okay, in other problems, it'll be something else. Subtract whatever that x was. So, subtract x. Subtract that value. So 100x minus 1x is how many x? Tell me, folks. 99x. Now you might be thinking to yourself, well, wait a minute, there's a whole lot of 7 2's that are repeating over here. You're not even talking about them. But knowing that this repeats in the same way that this repeats, by subtracting 72 hundredths out of 7272, you end up there. And step 4, solve for x and reduce / simplify wherever possible. Which means divide by the coefficient of x. X equals 72 over 99, which reduces by 9, which becomes 8 over 11. Okay? 8 over 11. Yes, ma'am. Yep. Like that? And if you double check your work in the calculator, 8 divided by 11, you get 72 repeating. Okay? This process, I guarantee you, you will see it on high school ACT, different types of tests. You're going to see this. So don't think this is just something stupid and annoying that you can live without. You need to know this. All right. We're going to do another one. Trying to find one that's a little bit different. All right. Okay. 0.4 repeating. Step 1, make the repeater equal to x. That was step 1. Okay? Repeater equals x. Step 2, count the number repeating. How many is there repeating, by the way? 1. And multiply by 10 to that power. In this case, we're going to multiply both pieces by what? 10 to the first power, which is 10. Okay? That results in 4.4 repeating on the left. Remember that 4, 4, 4, 4, 4, it repeats into infinity. And what's 10 times x? Come on, folks, wake up. 10x, bravo. Step 2, subtract the value of 1x. Yes, ma'am. Yes, please. And we decided that 1x is equal to this repeater, right? So we are going to subtract x, which is equal to that repeating 4. Which means 4 is equal to 9x. Final step, solve and simplify where possible. In other words, reduce. What is x going to be equal to? Mason, what's x equal to? All right here for you. It's already solved. What's 9 divided by 9? 1x. Is there a fraction over here? Very good. So what's the answer? You got it. To check it in your calculator, 4 divided by 9. And if you're lucky, you come up with the correct answer. 44444, which is exactly what we started with. 4/9 is the fractional equivalent to repeating 4. Okay, I'm going to do one more example of this with you. 0.12 repeating. What's step 1? Emma, what am I going to do first? Yep. So 0.12 equals x. Step 2. What do we do next? Noah?
How many digits there are you multiply, or you do the to the 10th power thing with that?
You multiply by 10 to the power of however many repeating pieces. So what am I going to multiply this by then?
2.
Yep. Multiply by that many pieces, which is 100. 10 squared is 100. So 1, 2, 1, 2, 1, 2, 1, 2, we don't need to keep going, times 100 is 12.12 repeating. What's 100 times x, class? 100x. Step 3, subtract the value of what 1x was, and that's what 1x was. It's whatever we started with. Subtract 0.12, subtract what the x was. 12 is equal to 99x. Step 4, solve for x. To solve for x, you simply divide by the coefficient. And x is equal to 12 over 99. We're looking for the fractional equivalent. You guys think that can be reduced at all? Probably by a factor of 3, I think. 4/33. You have to solve, you have to simplify. Okay, so there's several examples of how to perform taking a repeater and converting it to a decimal. It's easy when it's not a repeater, but when it's a repeater, you have to do this process. Okay, last thing, what if you have to put stuff in order? This will not take us but a moment or so. Example 6, putting numbers in order. If you're given a list, like say 2.7, 0.55, negative 0.9, 9/4, this is a lot of numbers, negative 9/8, and 13/7. Put them in order. I'll tell you how I do it. I convert them all to decimals. And then I put them in order. So I already know what this is. It's a decimal. I already know what that is. I already know what that is. 9/4. So take 9 divided by 4 and you get 2.25. Did you guys all come up with that? 9 divided by 8, negative. And you get negative 1.125. And then 13 over 7, positive. 1.857142857, looks like a repeater to me. So I am just going to go 1.857, and I'm going to quit right there because that gives me enough digits to work with. Of the list, the smallest ones are going to be the negatives, right? Which one's the smallest negative? Eli, which one is the smallest negative? $1.125 is the only negative. There's this negative and there's this negative, right? Those are your two choices. I didn't hear quite what you said, honey. I'm sorry. I'm sorry. Can you speak up one more time? Nope. It's this, honey. When you're going negative, the larger the number, the smaller it is. A negative number line looks like this. Just for sake of argument, okay? So 1.125 is going to be about here, and 9/10 is going to be about here. Of those two, the one that is the most to the left is the smaller of the two, which is 1.125 negative. Next is 0.9. Okay, now that we're in the realm of positive numbers, we've dealt with this number. What comes next? Ben? I don't see a 0.225. I see 2.7, 55 hundredths. Good. What's next? What do you think will be next, Stuart? You've got 2.7, 2.25. Yep. Leah, what's next?
2.7.
No, you sure?
2.25.
Yep. Last is 2.7. Now here's the bad news. For the ones that you converted from fractions to decimals, when you check odds in the back of your book, if you were doing an odd check, it would give you the answers back as what they were given to you as. Okay, so 2.25, it would tell you is 9/4. Negative 9/8 is what they would say instead of negative 1.125. And for 1.857, it would have written 13/7 because that's what they originally gave you. So the list would be given to you as negative 9/8, negative 9/10, negative 55 hundredths, 13/7, 9/4, and finally 2 7/10. Okay? If you are unsure at all about least to greatest, then you need to refamiliarize yourself with the value of numbers. Okay? Sometimes for some people, sketching out the number line is the most helpful way to do it because then you can see that what is the furthest left is the smallest and what is furthest right is the largest. Okay. All right, folks, this is going to take practice. Like I said, it's really not something I can